Today we're going to talk about the regression line, the regression line itself. So let's go, we're on page 73. So let's say that we did a scatter plot and we had a scatter plot that looked like this, and we drew a regression line that looked like this. And how did I find this regression line? LinReg, right? So we populated L1 and L2, right? Did the scatter plot, and then we did LinReg, which gave us the R value, y is equal to AX plus B, and we found, so y equals AX plus B is the equation of this line, right? Why do we find this line? What is so important about this line? What are the applications? What am I doing here?
It's the line of best fit, so it shows how strong the correlation is and the linearness.
Okay, yeah, that's all nice and good. But in the end, what we really want to do is we're trying to predict. We want to predict the values of something like this right here where I do not have a value. Right? I don't have a value. So if I use this line, I can say, well, if at this point, I can read it off over here and say, this is probably what it's going to be. My data shows that the value should be a certain point. Okay? So that's the whole point. That's the whole point of finding this line. Okay? So let's go to page 73. There's an orange box there. Read that, see if that makes sense. Interestingly enough, it says that the specific criterion for the best fitting line strategy is the least squared property. And we will talk about that in section 10.2, which just happens to be the very last chapter that we will talk about. Okay? So we will talk about this line being the least square regression line. Okay? Also known as the line of best fit. Okay? So we'll talk about why it is the least square regression line later on. Okay? So again, this allows you to predict. Okay? And now also, not in the book, but I should explain the two prediction models. Interpolation and extrapolation. Interpolation is when you predict within your data boundary. Okay? Extrapolation is when you predict out here, outside of the data boundary. Okay? Which do you think is going to be more accurate? Interpolation. So interpolation good, extrapolation no good. Not no good, but really not accurate, right? Not as accurate as you're going to be within the interpolation. Okay? All right. Now, one more interesting thing to point out here is that certain points here, at this point, I actually have a value. Correct? I actually have a value right here. But my line of best fit predicts something way up here, right? So there's actually a difference between the actual and the predicted, okay? So do you want this guy to be large or small?
Small.
You want it to be small, right? You want a line that gives you the smallest amount of these residuals if you add them all up. Least squared residual line. That's how you find that line. Okay, we'll come back to this in 10.2, but I'm kind of just planting the seed in the back of your mind here, right? Example number 6. Sam, read this for us.
Example 5 included a scatter plot of the 40 pairs of shoe print lengths and heights from data set 2, but in height scatter plot with the graph of the regression data, regression line included. Also shown is the stat display from the 40 pairs of data.
Go on.
Stat display, we see that the general form of regression equation has the y-intercept of
B naught.
b naught equals 80.9 and slope b1
B1.
equals 322. So the equation of the regression line shown in figure 219 is y equals 80.9 plus 322x.
All right, thanks. Appreciate it. So, if you flip the page, look there, you see that red line there. Okay. More importantly, on the right-hand side, you see the R, the correlation coefficient, and then you have the p-value, and then you have the y-intercept and the slope. So what can I tell from the p-value? What does that tell me? The p-value is less than 5%, therefore it is linear, correct? It's linear, it's going to be linear, all right? And then we have the correlation coefficient, which is 0.81, which is okay, right? Not really tight, but okay, all right? We also talked about the regression line being resistant or not resistant to outliers. Do you think they're going to be resistant or not resistant? Do you think they're going to be swayed
Yeah.
by outliers? Definitely, right? So these lines here are going to be swayed one way or the other if you have an outlier, meaning they are not resistant to outliers, correct? Okay, so you should be able to find the actual line using ln-reg. Then you should be able to predict a value if I gave you an x value, right? Which is nothing more than just putting into an equation and finding out what the y value is. Okay, all right. So if I asked you to calculate the predicted value, you should be able to do this. And sometimes if there actually is an actual value, you can actually predict or you can calculate the difference, the residual. Okay, we'll do that later on, not now. Okay. Any questions? All right, we're good for today.